And does this click? Great. Okay, cool. So thank you guys for organizing. Really great to be here. So I'm Manish. My background is computer science. I sit sort of half in a business school now and half in a computer science department. And hopefully what I'm going to talk about is relevant to the theme of the workshop. I've spent a lot of time in the last few years thinking about what happens when all of our information comes from shared sources and what sort of impacts that has downstream, how you should think about this as it comes to more sort of generative AI applications. So I'll talk through a few examples of where I see this being important here. I would love to have a discussion about this, so please stop me anytime. We have plenty of time. Perhaps the most pressing example, or the most high-profile example of this recently has been the conversation around AI slop. People remember there was a phase when Shrimp Jesus was getting very popular in the world. And this is an instance of sort of convergence of the culture, convergence of what people were getting out of generative AI. Part of it was just people converging, and part of it was also the technology was pushing us all in the same direction. I'm going to argue today that in a lot of applications, AI does bring convergence, both generative AI, but also just more traditional forms of algorithmic decision making. Would you like me to hide this? Can I do this? Okay. So I'll give you examples in a couple of places. One of the places that we can
click away the one on top.
Click away the one on top. Yeah, great. One of the places that we were thinking about this was in the case of pricing and antitrust considerations when multiple distinct, in this case, landlords were using the same pricing software to do rent pricing. There's a bunch of lawsuits going on in the US about this now. Some of them have recently been settled. There's concerns over financial stability and the impacts of everybody using quantitative trading models in the market. There was a New York Times story that came out, I think it was maybe a year ago, of a couple of faculty who had caught their students using AI to do their assignments. And so they had announced this, they caught a bunch of students doing it, and they got this flood of emails back from those students all saying effectively the same thing with the same phrases. They sincerely apologize for their behavior. And maybe not every single one of them was using generative AI to do this, but it seems like many of them were. So this is a big New York Times story. It just feels like it's popping up in a bunch of different places. Now, why is...
So you think of these as having the same source? I guess you'll
think of these as having the same...
These different stories having like the same...
So that's a good question. Like, what is common about these, and are they even instances of the same phenomena? I'm going to argue that they are in a particular sense. There's a few features that I think are broadly true of AI that appear in all of these places. One is that they are scalable. So once you create the technology, they can be used by many people with very low marginal cost. So once, in this example, RealPage creates pricing software for landlords, they can distribute that to many landlords effectively for free on their part. And so you can scale this across a very broad population very quickly. They're also flexible, especially in the context of generative AI, which means that I don't have to, maybe RealPage is creating rent pricing software, and that's very specifically rent pricing software. But OpenAI is creating models that can apply in a bunch of different applications, including writing emails apologizing to your professors, but not only, right? And so we can use the same model in multiple different places. We might see some sort of convergence across those use cases. These models are in general consistent. So many of them are deterministic. RealPage's pricing software is effectively deterministic. But even when they're not deterministic, if you use, let's say, ChatGPT multiple times, you'll get similar outputs every time you use it, even if not identical. And the last thing is there's some kind of smoothness property to these models, which says that, even if student A gives one prompt to a model saying, apologize to my professor, and student B gives a different prompt saying, I would like to write an apology to my professor, they still come up with pretty similar apologies. Now, those are not identical inputs. There's no a priori reason to believe that they should have identical or similar outputs. This is just an empirical phenomenon. I'll provide a bunch of evidence as we go through the talk here. And so, in my view, the confluence of all of these features gives us some kind of monoculture, where we have these models that can be applied at scale in a bunch of different applications, but they still enforce some kind of consistency and some sort of smoothness property across the many people and across the many applications in which they're used. Okay, so this is the lens on information filtering that I'm going to spend most of today talking about. before we get into it, there's a bunch of questions. There's technical questions, there's normative questions. Is convergence inherently a bad thing? Maybe it would be good if we could all get on the same page, if we didn't have these really polarized spheres, but actually everyone is sort of living in the same reality. So convergence is, in some sense, could be good. You could ask, what are some of the downstream consequences? So what is going to happen in the world? What happens to scientific discovery? What happens to journalism and news? What happens to social media as you start to see more homogenization? And what are the strategic responses to this kind of behavior? So how do institutions adapt? How do people adapt? How does the world adapt? And I find that this set of questions has been really generative for me over the last few years. Again, I'll give you a bunch of examples of stuff that I've worked on. I'll give you a bunch of examples of stuff that I've seen in the research literature that has been sort of exciting to look at. Today's perspective that I'll take will be mostly sort of computational, but there will be, I guess, a strong economic through line through it as well. I'll discuss what we know. So what are the sort of literature on this looks like so far? How do we go out in the world and actually do research on this? There's been a combination of theory and empirics that I think has been useful here. Give you some examples of research that I or colleagues or friends have done on the subject, and then some vague ideas of where I think some of this might be headed and where there is some interesting work to be done. And again, please stop me anytime. Would love to talk more about this. The last thing I'll say is a lot of the work in this space takes the perspective of formal mathematical models. And there are always questions. I mean, economists love to do this, computer science love to do this, scientists love to do this as well. But there always are questions of why are we doing this modeling stuff anyways? Why shouldn't we just be going out running experiments and gathering evidence in the world? And I think we need to do both of those things. I think this is particularly an area where it's important to think about the formal aspects, in part because AI is just in flux. It's really hard to predict what things are going to look like 5 years from now. And it's really hard to say that an experiment that I run today is going to continue to be valid 5 years from now. And so what we really need is some combination of the empirics and the understanding of what's going on the ground, but also some way to make valid or form beliefs, at least about the future, that are based on some maybe mechanistic understanding, that are based on principles of what's going on here. And my hope is that these models that we build abstract away from the capabilities that we have today and give us some kind of view of where things are headed. Now, I will say that any effort I have to predict where the technology is headed is probably going to be wrong in some way, but hopefully at least some of what we get here is going to be directionally correct. Okay, I'm going to start by talking about monoculture in the context of decision making, and this is really where I started thinking about a lot of these issues. So how do shared information structures impact decision making? And we're going to use that as a foothold to try to scaffold our way into more and more complex problems. There's sort of a roundabout reason that I got into this. So I spent a bunch of my grad school career studying fairness and bias in decision making. One of the applications that I spent the most time studying was employment. So when people are building resume screeners or perhaps more complicated tools to do selection, they would build these models, they would deploy these models into the world, and you could analyze the sort of fairness properties. What I thought at the time was a side point when I was studying one of these tools is I looked into their terms of service, and one of the things that they required was that you actually cannot interact with their service more than once a year. So they offered a service, it was a third party, they would sell to a bunch of businesses that were hiring, and they would say, here's an assessment you can run over applicants. Run them all through this assessment, and then we'll give them a score. You can use that score as a basis for your hiring decisions. And they would contract that to multiple employers. And so what would happen is if you applied to employer A and you took this assessment, in this case, it was a series of games that you would play that was intended to be like a psychometric evaluation. So you'd play these games, you'd get back a score. If you then, let's say you didn't do well and you didn't get the job, you would then apply to employer B. Employer B is also contracting out to the same third party. And instead of letting you take the assessment again, they would just directly forward your scores. Okay, so they would actually see exactly the same information about this applicant as derived by this assessment. And as with anything, you can find stories of people on Reddit being very upset that this happened to them, where you effectively just get banned from this particular segment of the market if you did really badly on the first application.
So it's the idea of if you get these correlated decisions that somehow then you get a more dispersed like search time for jobs.
So that's a good question. What is
more or less jobs, right?
Exactly. So the number of jobs is not changing. And so you could say like, okay, maybe this is bad for applicants. It seems kind of frustrating, but it's not clear that there's a social welfare angle on this, right? Is this actually doing something bad to the market, or is it just like introducing some amount of variance at the individual level, but like collectively not changing that much, right? So that was the question that we started asking here. Like, is there more to the story than just some people, are locked out of a segment of the market for 12 months or, whatever. They have to find other ways into this, into employment. Yeah.
How do you think about the incentives of the employer here? Like, obviously, there are settings where monoculture happens because all of us look at the same information, but there are settings where looking at different information is beneficial.
Yes.
Like if you can hire people that no one else is.
Great. You're like 3 slides ahead of me. Yeah. So, but that's absolutely the right question to be asking, right? So.
But wait for it.
Yeah. The first sort of thing is like there's some coordinated information across these firms. They can make rational decisions. People can make rational decisions. What does equilibrium look like in that kind of setting? Okay. And so actually, maybe you're only one. So the answer is actually, let's say you write down a model where you say, you and I are both hiring. We're looking at the same applicant pool. We can either choose independent sources of information or we can choose correlated sources of information. What is that going to do to the market, right? Are we just, maybe one of us will choose to contract with this third party, one of us will choose to go independent, and the world will be kind of okay. What you can find here is a sort of Bayes paradox effect that basically says we can all make rational choices to choose this common shared source of information, and it can still be bad for social welfare. Okay. And this is the result is we kind of wrote it down. This was 5 years ago. This was sort of my first opportunity to think about this type of question.
This is from the firm perspective.
From the firm perspective, yeah. So applicants just apply to firms. They get scored either, you can either choose to get a shared signal about their quality, or you can choose to get an independent signal about their quality. Those signals may have different precision and so on, right? Now, if the independent signals are more precise, everyone will just go with the independent signals and then there's no problem. But there's a regime where the common signals are slightly more precise, but they are also shared, and people collectively make bad decisions, even though that is the rational thing to do. And so both firms would actually prefer if you pulled away this common option altogether. But given that it exists, they will both choose to use it.
Sorry.
No, please.
And so how do they lose out? Because they make an offer to the same candidate, but not to the other?
Yeah, so one way to think about it is, let's say there's some very high, so we're measuring social welfare here as like the sum of the candidate qualities across those who get hired, right? And so what happens is when let's say the best candidate shows up and does a really bad job on the assessment that one time, on that shared assessment, if you had a second chance at evaluating them, that would actually be good. And they would be more likely to get a good outcome. But because you've made a mistake this first time around, they never get a second shot. And so both firms do that mistake.
Information loss.
Yes. And so let's see, let me see if I can, maybe I'll just draw out the results at some point, but let's see, let me try to go through it and then we'll stop me if it's still not clear. So the argument is, if there's some common algorithm that is more accurate than any independent decision maker, I might choose to use it, and that's going to increase my utility. If my competitor chooses to use it, it's also going to increase their utility at the expense of mine, right? So there's an externality here. And that information externality is what's going to lead to the loss of welfare. Okay. Basically, neither firm has an incentive to solicit new information, but contributing new information to the system is actually a social good, right? And so there's a positive externality of me soliciting extra information here.
Because that information somehow spills over to the other firm.
Exactly. And it does so because there's capacity constraints, right? If an applicant can only accept one job.
So it's kind of like a rational herding type of story.
You can view it as a rational herding kind of story. Yeah. I guess I would view it as sort of a Bayes paradox kind of story where once you add in the link that allows people to sort of efficiently travel down a path, everyone wants to do it, even though it would be better if only some people did it. Okay. And so that's the sort of information theoretic perspective here, right? Each decision maker is contributing information to a system. And so if we have independent decision makers contributing to a system, there's just more information in aggregate in that system, which allows better outcomes. Once you have correlation, or identical decision makers, we're contributing less marginal information per decision maker. And that sort of has a negative consequence from the wisdom of the crowds kind of perspective. you can extend some of these results. So I'll give you a couple different versions of this and tell you why I think they have different consequences. So Kenny Peng and Nico Garg had a series of papers a few years later where they used this sort of continuum matching market approximations from Azevedo and Leshno, where think of like a very large market, you have many, many firms, you have a continuum of applicants, and you just run a stable matching across these two. Okay? And you can ask questions about what happens when firms have correlated preferences over those applicants versus when they have independent preferences over those applicants, right? Or let's say they get independent noisy information about applicants as opposed to correlated noisy information. And what they find is what you might expect in the limit, it is better that everybody has independent evaluations because collectively you add more information to the system and it aggregates information in a more efficient manner. If you instead have everybody using the same shared ranking over applicants, you will of course make sort of a constant fraction of errors in the limit. Yeah.
There is a different notion of efficiency where it costs only one effort to produce one set of rankings.
Yeah.
And it costs potentially a large amount of effort to independently produce rankings.
Yes.
And so that would seem to push the other way.
Exactly. You're absolutely right. I will say that that is not something that I have seen in the literature. It's just sort of swept under the rug that let's say these all cost the same. But if it is cheaper to have one common evaluation, then that might sort of cut the other direction. And actually, maybe you're okay with worse hiring outcomes if it is much cheaper to get there.
And that seems, for example, like something that's relevant in a village setting, right? Which is that if each landlord has to independently think about their rent and this is costly, having one person do the thinking might be efficient, even if it is somewhat inclusive.
Good. Okay. So I'll talk about the real page example more in a second. Again, we're not going to think about the cost of information production there, but maybe let's come back to that because I think you're right. I will say that in practice, it is still costly in the sense that right now you have a bunch of humans who sit there and review the real page prices and then make decisions about whether to adhere to them or not. But maybe in the long run, that starts to go away or becomes cheaper.
Especially environment book. I have more go into this, so cool. It's not totally right.
Yeah. Good. And then the last thing I'll mention here is there's a recent paper by Bobby Kleinberg, Errol Sinanaj, and Eva Tardos, where they basically said the problem with this view of the world is that people are not behaving strategically. You're asking either, if everyone were to adopt this common algorithm, that would be bad, but rationally, would people do that? And so they extended our results and basically said, you find a price of anarchy of 2 in this setting, which says that I might have any number of possible information sources I choose from. Some of them are shared, some of them are not. Let's say everybody just makes rational decisions across a large market there. What does the price of anarchy look like? And basically they find that your efficiency only really goes down by a factor of 2, even in the setting where there's no price differentiation, right? It's just that if there is value in independent information, people will have incentives to solicit it. And so you can't have arbitrarily bad market effects because people are going to make smart decisions. Okay.
That's the price of it.
Okay, great. Price of anarchy is the ratio between socially optimal behavior and equilibrium behavior, the largest possible ratio between those two.
What units? Welfare?
In welfare units. Yeah, so let's say
utility, like welfare.
So let's say welfare here is measured by this. You have N firms, each of them hires one applicant. Each of those applicants has some intrinsic quality. Take the sum of all of that qualities of the people who get hired. That's the social welfare measure. And now we're going to say, world number 1, a social planner says, you're going to use this source of information, you're going to use that source of information, we're just going to assign it. World number 2 is everyone strategically chooses whatever they want. You find any equilibrium, and that equilibrium will be within a factor of 2.
And that does not depend on the specifics of the information structure.
They have a fairly general class of information structures that they allow. It's sort of based on distributions that have a particular concavity property, but it turns out most distributions will have that, like random utility models and like Mallow's models and that type of information structure will have this. And so their answer is, yes, things can get worse if you allow people to choose socially or shared information sources, but they can't get that much worse. So the market forces are kind of pushing the other way against these shared information sources.
So in that one, the statement is that the average quality of applicants can be cut by half, or that we're right.
Exactly, in the worst case. And you need sort of like pathological examples to get there. If you were to try to just randomly draw things from or randomly draw instances from distributions, it would be much better than that. Okay, so this is where my sort of initial thinking on this subject came from. If we limit ourselves to the context of decision making, shared information can lead to worse outcomes or to worse decisions. But those negative impacts are in some sense bound because of market forces, right? These information externalities actually matter. And as long as people feel those information externalities, they're incentivized to seek novel information. Okay, so where do we go from here beyond decision making? I'll talk about a couple different versions of this that, again, have been interesting to me over the last couple of years. One is that we'll look at some structured applications like pricing and so on that are not just about allocation and decision making. And then two, we'll try to think a little bit more about these unstructured settings, and I'll lump generative AI into this bucket of unstructured settings. It's not clear to me what correlation even really means when we talk about generative AI. Okay.
So just to recap from the previous one, right? Mm-hmm. I thought we would be going in a very different direction, right? It's about inequality between job seekers, right?
You could go in that direction. There's a great paper from Katie Creel, who's a philosopher, just like a few months ago, where she talks about the allocative effects of sort of correlation in monoculture. With another philosopher, Brian Hedden, we have a paper, which I'll talk a little bit about, trying to get at some of these normative issues as well. I will say it's not completely clear what the inequality answer is actually here. So for example, I'll go off script a little bit here. Nikhil Garg works a lot with, he's a operations research faculty at Cornell Tech. He works a lot on the New York City public school matching system. So this is in New York City, if you want to go to public school, you submit a ranked list of preferences over schools. They will do some lotteries on the background. They'll run a stable matching. You will get assigned to some school. And there's a bunch of questions about what is the right way to run that system, right? So one of the questions that has been studied a lot in that literature is on whether all the schools you should draw one lottery number that all the schools use for all the applicants, or whether each school should run its own independent lottery. And then you get a lottery number at school A, you get a lottery number at school B, they have different rankings over the students, right? This sort of almost directly corresponds to our shared information versus independent information. Here, there's no information, it's just shared sources of randomness versus independent sources of randomness. And you can ask which of those is better, and which one leads to more inequality or less inequality or so on. One of the things that Nikhil has found in the experiments that they've run is a big source of inequality is that not all students rank, no one ranks all of the schools. Everyone has some subset of schools that are like kind of reasonably close to them, and they'll just rank those. What you find is that if you have a longer list, you in general get better outcomes. That may not be super surprising to you, but the more schools you rank, the more chance you have of getting a spot at one of those schools. And one of the sources of inequality is better resource students are the ones that have longer preference lists that they write down. Worse resource students tend to write shorter lists, and they correspondingly get worse outcomes. Now, one thing that you find is that the impact of having a longer list is much higher in a world where you have independent lottery numbers than in a world where you have a shared lottery number. Okay, so these independent lottery numbers sort of magnify the inequality. And this is sort of has to do with some of the results that we talked about before. You get more of a vehicle for inequality versus if you were to just have a shared lottery number that applies to all students. Okay, so the marginal benefits of more ranking more schools goes down. So you can start to talk about the inequality angle over there, but it starts to get a little messy.
It's yet another angle, right? It's like, if this is like about the correlation between prior privilege and what school you go to, as opposed to, I guess, what you started off with, which was like, if you get rejected from one job, do you get rejected from all the jobs? It's kind of a little funky because the outcome is binary, so
yeah,
the opportunity is clearly more unequal.
So that's a good question. Is the opportunity more unequal? Potentially, right? In a one-shot setting, if there's N jobs and N people are getting hired, then there's a fixed level of inequality no matter what, right? So in that sense, in the one-shot case, it doesn't really matter. Now you could say, is this doing something over time that is unequal, right? That either you get a job in every time period or a job in no time periods, and that's bad. And that sort of depends on like how much does the world change year over year, how much does the applicant pool change year over year. The one thing, so I think your intuition is roughly right. I think the one thing that I would add as a caveat is you should view the more accurate sort of aggregate technology as the one that's going to lead to more inequality, right? So if I have lower overall variance in a screening process, that means year to year, I'm going to get more similar outcomes. And that should actually lead to higher inequality. So one way to ask that question is then, is it a more accurate aggregate screening technology to have monoculture or not? And this result says not always, right? It says sometimes it's actually less accurate to have a monoculture. And if it's less accurate to have a monoculture, then there might be more year-to-year variance and therefore less inequality. So it's not clear exactly what the relationship is there.
On this monoculture leading to externalities and efficiency, is there a statement relating the underlying environment and whether it was efficient or inefficient under, say, common information to like what happens when you add the monoculture? Like the reason I'm asking is I have this sort of intuition that like if you start with an environment where the welfare theorem goes through and then you change the informational environment without changing the underlying game or technology, the welfare theorem might still go through. And so it's harder to say anything. Whereas if you start with an inefficient environment, the monoculture interacts with the existing inefficiency. But that's kind of vague, but
yeah, I don't think I have a good answer to your question. I think all of the results that I've seen have basically been like, here is a completely independent information environment. We're going to take that away and swap in a completely dependent information environment and ask about the difference between those worlds, or maybe we'll have a continuum between them, which is some of the stuff that I'll talk about in a second. But usually it is efficiency is sort of comes from the equilibrium behavior, or efficiency or inefficiency comes from the equilibrium behavior in that particular information environment, whatever it happens to be. That's where all of these results are sort of situated.
well, so I mean, again, I come from background, but there's like an economics like theory of the second best, which sort of says like you can rationalize all kind of crazy policies if you start with an inefficient economy and then use your crazy policy, which is actually usually making things worse, to deal with the pre-existing inefficiency. So I'm trying to kind of relate that to this.
Good. Yeah, I don't know a particular model where people have said like, here's the prior inefficiency that we are starting with, and now we're going to look at the sort of direct impact or the sort of incremental.
Like in these hiring examples.
Yeah.
Are they starting with an inefficient economy under independent information?
I guess it's not a starting point, ending point. It is just two independent worlds. That's the setup that these things typically take. I think it would be interesting to think about what is a reasonable model of what's actually happening in practice now, and then what is the endpoint that we get to once you add in this particular shared information structure. That's typically not the thing that has been studied so far. Okay, good. So let's talk a little bit about structured settings beyond decision making. So we'll think about what is the dependent structure of the errors that we're going to encounter, and how does that impact whatever setting we are interested in studying here. I will say that this is a more general sort of class of problems that people have been studying, these correlated errors or correlated failures. The hypothesis is that even if we don't use identical models, if they begin with shared components or they're trained on shared data, they will make correlated errors. And we can ask, what are the impacts potentially that those correlated mistakes might have? And where do we start to see some of this happening in practice? Okay, so there's a series of papers that does this in the context of multiple choice benchmarks and large language models. So if you haven't seen, there's lots of benchmarks that are just like, here's a standardized test effectively. We'll make them all multiple choice and we'll just ask a language model, is the answer A, B, C, or D? Here's the question, here are all the choices. And you can ask, what is the dependent structure and the errors that models make? Do they always get question number 35 wrong, right? For whatever reason. If I know something about whether model A has made a mistake, what does that tell me about whether model B has made a mistake? And one thing that you generally find in this literature is that you do find a lot of correlated errors. So each row and column here is a large language model, And then this is sort of high correlation, high agreement, low agreement here. Same thing over here. These are on two different multiple choice data sets. And then the plot on the right basically says that as these models get larger, you end up seeing more correlation, not less. Why? It's a good question. In part because it's sort of hard to normalize out the baseline accuracy of these models. And so what happens is if they're just getting more things right, then the subset of questions that they're getting things wrong on kind of converges to the hard questions, which I'll talk about in 1 second. And then in part, there's a broader potential answer to this, which is there's a whole line of literature on model multiplicity, which maybe people have heard of, which basically says if you want to get 70% accuracy on a data set, there's lots of ways of getting 70% accuracy. There's lots of models that will have sort of similar performance. And it's sort of a question, are they going to agree? Are they going to disagree? If I hand you two linear regressions that are sort of have the same mean squared error, are they making the same mistakes on the same instances? And one answer from that literature is eventually, as models get arbitrarily accurate, there's no disagreement because they have to get all the questions right. But somewhere along the pathway to getting there, you should see a period.
An identification argument.
Exactly. There's only one way to be 100% right. There's lots of ways to be 70% right. Right. So eventually you have to get to complete agreement. On the way to getting there, the way that you get there is through these sort of bias variance trade-offs where you say, I could get more accuracy by making my models higher variance at the cost of less bias or vice versa. And so depending on the path that you're taking to getting to 100% accuracy, you actually see different effects. Because if you increase variance, then you see more and more disagreement. But if you increase bias, if you increase bias, then you should see more agreement because you're reducing variance corresponding. So I'm not exactly sure what's going on in this case. It's really hard to convince yourself or convince someone else that this is like a measurement artifact of some sort. Versus like truly you're seeing more.
Like there's a few things going on, right? Like there's how you define like correlation errors. There's the question of is training data the same, which is different from sheer variance.
Because we know that all of these models are sort of pre-trained on the same data, but we also know that they have very different post-training procedures, and that sort of steers them in a bunch of different directions. And so the question is like, is it actually qualitatively shifting the types of mistakes they're making, or is it just changing the form, but actually they still have the same information base, and that shared information base is what's leading to this correlation?
This might be out of left field, but like if you gave these multiple choice tests to humans and then bucketed them by their accuracy, would you see the same pattern or a different pattern? I
mean, so you will. So I'll say this in the next slide, I guess, but that you will see some of this. Part of the reason that you see this is people get hard questions wrong and easy questions right. So if you see a lot of agreement on easy questions, that shouldn't be super surprising to you. So we actually ran an experiment last year where we basically said, here's us trying to reproduce what these models or what these sort of prior papers had found on the correlation structures, where they tried to account for the fact that some models are more accurate than others, but they didn't account for the fact that some questions are more difficult than others. And so if you try to account for that, a lot of this apparent correlation actually goes away, at least on some data sets, where you basically say, I'm not surprised by correlation that can be explained by item level heterogeneity. So if I tell you that I'm no longer surprised by that, I find less overall surprise in these results. It's not clear that this is the right null model, though, because you could have said, actually, the right null model is like, every question has some math difficulty and a reading comprehension difficulty. Every model has some math capability and reading comprehension capability. And that two-factor model actually should be what I use to explain disparities or sort of correlations in my data set. If I had an even more flexible model, I would find even less correlation. Is that the right null model of the world? I'm not really sure. Right. And so part of the point of the paper that we wrote is to basically say, like, this is inherently a subjective activity, and you have to assert what you think excess correlation is relative to some null model, but somebody has to specify that null model. Otherwise, this whole thing is sort of ill-defined.
I'm going to ask the question is, can you use this to detect AI-produced answers versus human answers?
Good. I will talk about that in several slides, but sort of yes. One thing that my co-author Nikhil was a co-author on this paper, and one of the things that he did notice is you can actually find instances of people very clearly stealing each other's training data. Because if they make literally exactly the same errors as some other model, you kind of know that they sort of distilled that model somehow. So they didn't put it in the paper because they didn't want to get sued, but you can actually find some combinations of models where it's like these have very identical performance structures. Okay, I'll give you a very different example of where I think just sort of qualitatively we can start to think about how shared information might impact your view of the world and how it should impact your view of sort of institutions. There's lots of institutions, including markets, but especially democracy, where some amount of independence across participants is not a necessary precondition necessarily, but it is an argument for why this institution is going to work, right? So the classical Condorcet jury theorem says, if you have voters who are more accurate or more likely to be accurate than not, and they're all independent from each other, then in the limit, those voters are always collectively right. Okay, now, there's lots of reasons why you may not believe that voters are actually not, in fact, always collectively right. But one of them is that independence is doing a lot of work here, right? The assumption that these people are behaving independently is driving a lot of this result. And if you were to write down a model where, in fact, there is some dependence in the information structure that they have, you would find that in the limit, they are not always independent. So if you write down like a beta Bernoulli or beta binomial model of what's going on here, that there's some sort of likelihood of being correct that gets drawn from some distribution and that people are independent relative to that, you find that there's actually ceilings to the collective accuracy of this system. And this is just, I don't know, I had Claude run some simulations, so don't take these plots too seriously. But this is just sort of a basic argument that without an independent structure, you have some problems with your sort of foundational facts about why you believe in democracy.
Saying that the law of large numbers doesn't really kick in if you have sufficient early.
Exactly, right? You don't get concentration if you don't have independence.
Yeah.
Right? And again, this is just a toy example that you can run, but the general point is that it's interesting to look through what are your beliefs about the world, where do they come from, and where do they rest on different people doing different things or people being independent in some way. Some of my thinking about this actually came from the fact that one of my postdocs was voting in the Cambridge, not this Cambridge, but Massachusetts Cambridge, in the local elections there, and she was trying to research some of the ballot measures, and so she went to ChatGPT and did some research there, and then she had this realization that like many of the voters were probably doing very similar things, and so in fact you do have this very common piece of information, which is what does ChatGPT think about this ballot measure, and that was actually driving at least some of the views of the world that people are going to have here. Okay, so I'll return to this real page case in algorithmic collusion. Again, my view of this started in October 2022. There was this ProPublic article that many people may have seen here, where they were looking at this company called RealPage that was being used by a bunch of different landlords to price rent. And this was just investigative journalism at the time. Their argument was that they can coordinate prices and price increases simply by pushing them out to multiple landlords simultaneously. And they were, in fact, trying to drive price increases. Part of this, if you look at RealPage's argument, they basically say that landlords are systematically underpricing, that they are averse to vacancies, and they should be less averse to vacancies and raise prices higher and be okay with slightly lower occupancy rates. And their argument was that that was true in isolation. That wasn't about collectively raising prices across the market. Their argument was that it is rational for a landlord to raise prices even in isolation. But the effect that they're having was not in isolation, because they're able to do this simultaneously, and you're actually dramatically reducing the risk of being undercut if you can get all your landlords to raise prices simultaneously. After this article was written, there were a bunch of these lawsuits in the United States against this company, RealPage. There have been a bunch of settlements since then. It's also just a generative source of research ideas, right? So there's been a lot of academic activity in the law community, in economics and computer science, trying to think about what does algorithmic collusion mean? When is it illegal? Should it be more illegal than it currently is? How would we apply existing frameworks? Yeah.
Is it the problem from the landlords or from the company? You say it's to the company, but the landlords are using the algorithm, right?
Great. So the legal theory here is what's called a hub and spoke conspiracy, where there is one centralized aggregator of information that is colluding simultaneously with all of these other spokes or these landlords to engage in illegal activity. There's a case in the US, I think in like the 80s or something, there's a company called AgriStats that did a similar thing in the like livestock feed pricing. So like how much are cattle over here, how much are cattle over there? If we can aggregate all that information, we can better understand prices, but also better coordinate prices. One of the things that came out of a recent settlement in the RealPage case was they're allowed to keep doing what they're doing, but there has to be like an information firewall between landlord A and landlord B. So information coming from landlord A cannot be used to set prices for landlord B and vice versa. And so they're basically trying to break their ability to operate as the central coordinator in this kind of alleged hub and spoke conspiracy. I will say that like it's very hard to show that there's any collusion going on here. A lot of the requirements in the US, you need some form of intent, like they sat together in a cigar-filled room drinking whiskey and agreed to increase prices. And there's no strong evidence of that here. They did do some stuff that made people concerned. So they were very pushy about forcing people to accept their prices. And if you started to decline their suggestions, they would like hold a seminar and bring your management personnel in and be like, hey, we really think you should adhere to the prices that we're giving you. Again, they will say that this is individually rational, that they're trying to help people get the most out of the pricing software that they're offering. But that is that's going a little bit beyond just providing recommendations. There's some amount of like collusion or collusive looking behavior going on.
If their interest is because they get a percentage or something, or?
I mean, I don't actually know what their fee structure is, but if you're raising prices through this software, you feel good about the software, you continue paying them your subscription and so on, right? So they have a vested interest in making sure that you make more money because then they will eventually make more money.
You also optimal to use the software and reduce the price a little, right? Like,
so that's a good question. And that actually gets into some of the challenges in writing down economic models in places like this, because if you write down models where there's perfect competition, stuff like that happens, and then none of this works, right? Because it's like these two companies are sitting right next to each other, and you raise the prices a little bit, everyone goes and fills up your apartment complex and whatever. So we tried doing some of this. You have to do some kind of like a little bit hacky stuff to get the models to go through. And I don't know if economists love what we've done, which I'll show you in a second. But
it would be like a version of these like second best stores or whatever, right? You have a little bit of friction here, and then
exactly. So that's what
is there, and all of a sudden this really gets amplified.
Yeah, so that's what you model. Like there's some amount of some amount of friction in the market, you know, whatever. Just undercutting your competitor doesn't guarantee you 100% market share and so on. Okay, so I'll show you that here, actually. So let's say you write down some sort of oligopoly model with friction, but you have a correlated error or signal structure. So let's say I'm going to estimate your willingness to pay, and that's going to be noisy, so I'm going to be wrong sometimes, but I'm going to price accordingly. Does it help me if my competitor, when estimating your willingness to pay, also makes the same mistakes that I do, right? Every time that I overestimate your willingness to pay, does my competitor also do so? If so, then I'm less worried about being undercut, right? Because, you know, we're both going to set the same prices. There's just sort of less competition in the market, right? So it turns out that yes, these correlated error structures do allow you to price more aggressively. It also creates some weird incentives for the production of that technology in the first place. Like if I wanted to create models that had more correlated error structures, what would I do? I would make this biased variance trade-off accordingly, right? I would train really, really simple models. I would train logistic regressions, because even though they're going to be less accurate overall, they are going to introduce more correlation because they're lower variance class, right? So you can actually run these experiments where you say, we're going to train models on different data. We're going to use either more complex models or more simple models. What is the rational choice here? And you actually find that equilibria are better for firms if they train these simple, bad, but low variance models. Yeah.
Is that contingent on the idea that all of the simple models will have the bias in the same direction? Like there's something about the correlation of the bias.
Yeah,
that's implicit here.
It's exactly contingent on that. And so that's a little harder to do theory on, and that's why you just train the models and see what happens. And you find that, in fact, yeah, like especially if I just partition IID data into two data sets and say, you're going to train a logistic over here and a logistic over there. For like reasonably large data sets, you get identical or near identical coefficients by doing it, right? So you actually, and the same kind of holds if you say, well, you're going to take data from California, you're going to take data from Texas, and they're still actually going to end up being much more correlated than if we train random forests on those two data sets.
Right, but like with like I run my regression in logs and you run your regression in differences or something like that.
Yeah.
they could both be simple,
Absolutely.
but could generate pretty different outcomes. So like, I guess, I don't know the prior events, but it seems like that's important.
Yeah, so there's the choice of model is not the only source of variance in this process. And so you're right that in our experience, we like hold everything else fixed and just switch out the model class. You could do more general things. You could also just look at the market and see what people are doing in practice. Okay, I'll give you a few more examples, I guess. One is one of my colleagues, Mariam Farbudi, has this really nice paper recently.
But sorry, just like to understand the statement there, the simple model,
Yeah.
the more complex model would be less correlated because it's kind of looking more locally in the data, and so kind of the random shocks in the data are independent.
Yeah, so the learning theory way of stating this is you ask about what is the variance of a model class, which says if I drew an IID data set, trained a model, and I did this a bunch of times, how high variance are the predictions coming out of that class of models, basically. Right, so it's in some sense like how much does the variance in the data propagate forward to the variance in the predictions of a model trained on that data? And it turns out you can just really nicely characterize different ML model classes in terms of their variance.
But the correlation across, say, different landlords in terms of the recommendation they get, I mean, if it's something like kind of a local average or whatever that the prediction produces, right, then it's like if it's a smaller local neighborhood, then it will get less correlation. It's like a landlord that's a bit further away.
Yeah, okay, good. So some of this is inherent in the specification of the task that you're solving as well, right? Like what is the input stream that you're getting, what sort of outputs? And if you say, I'm going to constrain my input stream to be super local, I would get one sort of level of correlation across space. And if I said I'm going to actually use like statewide data as input here.
Sorry, but what I meant the local, I guess, is like just what the complex model does.
Oh, mechanistically, yeah, it's kind of hard to say, honestly, which is why the learning theory perspective is like, I'm going to abstract away any of the mechanics of how this works. And I'm just going to ask, if I were to train the same model twice, how different would it be? Right, on two IID samples of data, how different would it be those two times around? And I don't need to know anything. I mean, in order to answer that question, I could just do a bunch of experiments and find out the answer. I don't actually need to know stuff about the inner mechanics of that model. It turns out that more flexible models like random forests and especially neural networks tend to be higher variance. Like every time you train them, you get a very different thing. And like heavily regularized models or regression, those tend to be really, really stable. So it doesn't really matter exactly what the realization of the data is. You get basically the same model every time.
Yeah, sorry, I don't mean to this, but that's different from like having high correlations across recommendations you give to two different people, right? And that high correlation is not like comes in simplicity basically because that the predictions get more similar, simpler. It's a difference.
I guess so. The argument here would be that you're giving recommendations. You're training, a model over here and a model over there, but you actually train them through very similar processes, through very simple models, and so you know that those are going to give you very similar predictions, even though maybe they're taking in different data or they have different structure behind them. This again, a lot of this depends on precisely the setup you have. Sometimes you're actually just using literally the same model for everyone, and this question doesn't really matter. But then sometimes you're shipping out slightly different models across geography or something like that. Okay, the related example to this I wanted to give was from my colleague Mariam. So, she studies she's in the finance world, so she studies credit markets. And one of the things that she wanted to model was credit markets where you have correlated screening technology. So you have a lender who makes some mistakes, and you have another lender that makes some mistakes. How do you say that those lenders make similar mistakes in predicting risk? And the thing that she makes sort of endogenous here is what is the precision and cost of the screening technology? So this gets a little bit to your point about, these have different levels of cost associated with having more or less precise screening. And what you get, so if you write down a model where she calls it nestedness, where basically you say that if a better screener makes a mistake, a worse screener is going to make that same mistake. They're going to make more mistakes, but they're definitely going to make the ones with the better screener. You get a market structure that basically looks like a traditional credit market, which, low interest, high precision screening. And importantly, the people who get credit in that market are the people who are not opaque from an algorithmic perspective. So we're very easy to read. You can very easily assess their risk. And once you sort of skim off that cream, you're left with this this market of subsequent increasing opacity of these applicants. These people are pretty hard to read. These people are even harder to read. These people are even harder to read. And you actually get priced according to how opaque you are to a model. Okay? As opposed to necessarily being priced according to your underlying risk. It is about how algorithmically legible you are. And so there's some
But
politics.
it's different from just the risk aversion type.
Completely different from risk aversion. It basically says that if you were legible, if you looked legible to the sort of traditional market, you would have already gotten a low interest loan there. And so the only people who remain are the people who are kind of hard to read, thin credit files, that kind of. And they actually find that it's not clear whether like policy levers like data sharing and transparency are actually helpful here. You get weird results where actually sometimes it can make things worse, and it can sort of extend out this, what they call the hockey stick structure of this market. I think this is the last example I'll give you in this sort of structured setting is on social learning, which hopefully some people here have come across. These are, I think, really particularly interesting to me. It's something that I'm continuing to think about today, and I don't really have good answers on. So in models of social learning, you're basically trying to understand how do we collectively acquire information. There's classical models from economics on sequential social learning. In those types of models, you make a decision based on your own private information and what you've observed that people have done in the past. And in these models, the failure mode that you see is typically herding, where you say, I have my own private information, but actually the last, everyone who went before me took some particular action A. My private information kind of leans me towards action B, but because I'm going to go off of, all those people before me probably weren't wrong, that should outweigh my own prior belief. And my posterior will be that A is actually the better option. So I'm going to throw away my private information entirely, effectively, and go with option A. And if enough people do that, then nobody's prior is strong enough to shift the beliefs they get from looking at what the people in the past have done, and you get hurt, where nobody is contributing information to the system anymore. Everyone is just going with what the people before them have done. There's a similar model that you see that's come up pretty recently, combining some ideas from online learning with sequential social learning, they call banded social learning. And this is a model where, let's say there's two actions that I can take. Each one has some payoff associated with it. And I just have to pick one. I get the payoff corresponds to whatever I chose, and everybody gets to observe that. The failure mode here is that we, again, all keep picking action A because we think it's the best action. We were maybe wrong in our initial assessment of B. We got unlucky a few times, but now nobody wants to take the risk on B. Everyone knows that A is in expectation better, even though in actuality it may be worse. And this is where you get exploration failures. So no individual is going to benefit from trying these risky options or the underexplored options. And you get collective failures to learn in these types of settings. Okay. Now, why am I talking about this? This is a different kind of mechanism for shared information, right? The failure mode from both of these comes from the fact that you get to see what happened to everybody before you. You have full information about the world as it has progressed up until you, and everybody that comes after you will have that same shared information. One thing that you find in these literatures is if you put the world into different information silos, things actually get better. So, you only get to see the outcomes for the even people who came before you, and the next person's only going to get to see the odd outcomes. So you have two parallel information silos. You get fewer exploration failures in that kind of thing. And so you can prove theorems.
Eventually the information gets merged.
Yeah, let's say eventually the information gets merged, right? So it's better to have a period of time where things progress independently, and then you merge all this at the end, right? And so you can prove theorems. We have a paper recently where we do some version of this, where you basically say, let's go into this banded social learning world, two arms, each one is going to generate this banded feedback. What you get is some non-zero probability of converging on the wrong option, right? So it's actually quite high when you have this, the x-axis here is like how much common information there is about all possible options before you start progressing this. So this is like, we start with literally zero information about the world, and this is, we start with a lot of information about the world. And then you just run these banded trials, and you get a lot of this exploration failure behavior where everybody just picks the arm that currently looks the best. And sometimes that converges very quickly without actually ever trying out the second best arm or what looks like the second best arm enough. Okay. And so the takeaway that I have is shared information is efficient in the short term. So for me, I would rather just see all of the information that's happened until now to make the best possible decision for me. But in the long run, it can be inefficient because there are, again, information externalities. Me choosing the lower mean, higher variance option provides information to everybody who comes after me. Because, let's say it's a new restaurant that nobody knows anything about and it has like 3 reviews. It would be helpful for all the people who are going to come after me if I tried out that restaurant, wrote a review, whether it was good or bad, because that's going to contribute information to a system. I contribute less marginal information if I go to the thing with 1,000 ratings. Okay, so this is the general playbook that I think is interesting to run in these structured settings, is look for places, maybe it's in research, maybe it's in personal experience, maybe it's the world more broadly, where independence appears to be a load-bearing assumption of some kind. And ask what happens when we lose that independence? What goes wrong? And for me, the useful toolkit has been some combination of game theory, decision theory, information theory, generally knowing things about probability, knowing about sequential decision-making. All of these things together seem like the right toolkit to at least develop theory for this type of work. Okay.
And just to recap for myself, I guess, like there's some quite different normative concerns, right? That's
absolutely
that are there, right? One is like you're just not acquiring enough information in aggregate.
Yep.
Because it's the one you emphasize the most, which is different from like I don't know, rental prices are too high for everyone, which is again different from the generating inequality.
Yeah, I don't think there's a single set of normative issues that is like the right one that intersects with this. I think it touches on a bunch of different concepts depending on where in the world you're thinking about it. So collusion is one, welfare is another. I think agency, which I'll try to talk a little bit towards the end, is another one of them. So in what kind of world do you have agency to increase your own state through effort? Is that a good thing or a bad thing? What's the intersection with inequality? I think there's a bunch of interesting questions there. Again, Brian and I tried to write down some of these when we were sort of thinking about what are the normative issues around monoculture. The things that we mostly focused on were the systemic exclusion arguments. So are you getting locked out of a market? Is that bad? The agency ones, which I think we don't have good answers for, but I think, well, you can read the paper, I guess, to see if you agree with what we had to say. But it's basically like, it could be good, it could be bad. We really have to actually study this empirically or develop good theory to know. And then the questions around social learning, which I think are actually maybe the most interesting ones. So the place where I'm have the least answers for what are you supposed to do about any of this.
And what you haven't mentioned, I guess, is like things like Stack Overflow or whatever, where everybody stops asking questions there and posting it.
Absolutely, yeah. But there are good models of
it's a very similar flavor in some ways. Right?
Yes, yeah. So Omar Ben-Parat has a paper on this, like explicitly modeling, like what is the game theory of Stack Overflow, where people are contributing, people are also using AI, but contributing to Stack Overflow makes AI better. You get some sort of knowledge collapse. Theron and Asu and one of their students have a paper about knowledge collapse in the sort of more economic version of this. So I think it intersects in a lot of those concerns there as well. Okay, so the last thing I'll try to talk about briefly is how do we apply any of this to unstructured settings? And I will say that this is going to feed into my talk tomorrow, so I'll have more stuff to say about it there. Question number one is like, what does correlation even mean when like you're using ChatGPT and I'm using Claude or something like that? I don't even know what it means for our output distributions to be correlated there. I'll give you a few examples where I think this has been sort of interesting. There's a lot of applications on the creativity side of things, which I've been increasingly interested in. So what does it mean for creative production and markets for creativity when there's a technology that produces a lot of stuff that looks very similar or kind of the same field? What happens to the value of that kind of art in that world or creative production? What happens to the value of human-produced stuff? Does it go up? Does it go down? There's also questions about scientific discovery. I think this is happening at different rates in different fields, I would say, but we've all come across some version of automated scientific research or the promise of automated scientific research. One of my friends, Chen Hao Tan at UChicago, runs this platform where every week people submit research ideas. and they create some AI generated research ideas, and they have a community just vote and see like whose research ideas do people find interesting. I think they're trying to get to the point where eventually they take the top few of them and just like try to run an auto research loop and see what happens over the course of the next week. So there is some push towards automating scientific work and scientific discovery. You see this especially happening in the math community now, where mathematicians do a lot of work. Some of that work looks like theorem proving and some of it doesn't. And a lot of the theorem proving side of the world might start to get a lot easier. So what is the value of mathematics? What does a mathematician do? How is generative AI going to impact that profession? Now, if we try to put this in the framework that we've been describing so far, where it was about formal correlation and maybe some vague notions about shared information, it's really hard to see how you put LLMs or other big AI models into that buckets. So what does it even mean for high dimensional outputs to be correlated? There's empirical questions about, are they correlated in practice? And is that going to change over time? What are some of the technical limitations against that happening? And what sorts of applications should we be thinking about? I think this is a pretty broad space. There's just so many things where, you know, the value of human independence has been high and kind of underappreciated in my view. And we're going to start to see a lot of that put to the test. If I had to try to articulate what I think the actual mechanism going on here, it's something like this. For structured outputs, we seem to believe that models are smooth. So we seem to believe that if you and I train models on shared data and we had more shared data, we would have more correlated models, right? That's like a belief that we have that is, I think, empirically true, but sort of hard to mathematically make well-founded. We have similar intuitions that if we start from the same pre-trained language model and then maybe we do some post-training in different directions, we're probably still going to have some shared information sources and therefore more correlation in what we produce. But there are some technical questions around this. So why would we even believe this in the first place? So why do we believe that two different prompts are going to give us similar outputs? Like, why don't we just get arbitrarily different things if we change the spacing, change one word? And then, so there's questions about the use. There's also questions on the development. So two different companies might train their models, but fundamentally they're kind of using the same internet as their pre-training structure. Are you going to get similar behavior? They have similar sort of knowledge bases in their underlying models. And is that going to lead to correlation or similar outputs? In structured settings, the way that we basically do this is we say, you measure things are similar if they are exactly the same or if they're identical, right? So, or if I have a real value output, I can say use distance on a real line away from each other. But in general, it's pretty easy to say what it means for two models to have similar outputs. With high dimensional data, you will almost never get exact equality. So even a model will never output the same thing twice, or unlikely to output the same kind of long piece of text twice. Two models are very unlikely to output exactly identical things. So the probability of collisions is roughly 0. But on the flip side of that, even if you don't have identical outputs, if they are similar to each other, that should mean something, right? It shouldn't be binary, either they're the same or not. You should have some kind of smooth notion of similarity here. And so you could ask, what should we do instead? And I'll tell you a little bit about what people have tried doing instead. There's basically two things that we've done in the research literature so far. One is to create discrete structure where it didn't previously exist. So you effectively cluster and categorize data, right? So you say, there's this, I'll give you a few examples of this, but like, we want to know if, peer reviews written using AI look more similar to each other. So we're going to say that certain phrases or certain words have become more common, and that's how I can sort of track the use of AI here. So it might be specific words, it might be clustering, it might be like, I'm going to extract some features like this is a positive tone or a negative tone or something like that. And so I'll look for collisions in that reduced dimensionality space. And the other thing that we do is, in those sort of very used language models to solve this problem view of the world, is to say, I don't know, I'm just going to put these all into some geometric space, we'll call it an embedding space, and I'm going to measure similarity in that space. So even if there's two pieces of text that are qualitatively similar, even if they're not identical, I'm going to hope that they have similar looking embeddings, and I'm going to use that embedding similarity as my measure of the world is getting more sort of converged on.
Operational autoencoders are basically designed to do exactly that.
Yeah, but this is usually, we will not train our own models to do this. It's just, I'm going to go to Hugging Face and download some text embedding model and then get whatever that thing says. So I'll give you examples of both of these. And this is an example of an RCT that has been increasingly common is the RCT where half your participants get ChatGPT access, half of them don't. You see what changes. Okay, so this is an experiment run a few years ago, and they wanted to know how similar people's writing was if you give them access to AI versus not. You can tell, but with all these like by the models that were getting used, roughly what vintage this particular study is. So there's a lot of results in this paper. This is not even the main one, but I think it's a good example of the thing that I'm talking about. The metric that they were looking at is, let's look at all the 5 grams in this paper. So consecutive strings of 5 words. Look at this across all of these essays and just make the histogram. Okay. So the most common 5 gram appears with this probability, like 0.00035 or something like that. Okay. Now that's not very common, but you'll see that it is much higher in a world where people are using what was at the time InstructGPT versus if people are writing things by themselves. Okay, so there were specific phrases that were happening kind of much more often with AI use versus not. One gap that you'll see here, which I think is interesting and comes out a lot actually in this literature, is GPT-3 is just the base pre-trained model without any instruction tuning. It's just sort of the fancy autocomplete engine. And then InstructGPT, which is in blue, is the model that actually has been post-trained. It's instruction following. And you see that GPT-3 is actually a lot closer to the human distribution than it is to the InstructGPT distribution. Okay. And your hypothesis might be that post-training is actually doing a lot of this homogenizing work, right? That actually the base model looks kind of similar to a human distribution, but once you get to try to make it like a helpful, friendly assistant that follows instructions, you sort of narrow its view loop. And I think that's kind of true. That shows up in a lot of experiments. And there's
kind of
some
makes mechanical sense in terms of the post-training data being a lot smaller, but also hand curated in a much more homogenizing way. Right?
Yeah, so there's a few explanations for why this might happen. One of them is more technical, which I'll get to in a few slides, and then one of them is like the human language does a lot of things, but once you say I actually want it to be a helpful, useful assistant, that's like only a narrow subset of humanity that you're sort of trying to get it to emulate, right? Most people are not helpful, friendly assistants, right? So yeah, there's a few reasons for this, but it seems to be empirically true in a lot of the studies where it's sort of hard to do this direct comparison because if you don't have instruction following, then like, what does it even mean to interact with this model and converse with it? So like, there's some weirdness in there, but in general, you'll find results that look like this. Yeah.
Quick clarifying question. How should I think about the language in Sanskrit? Like what do we cover?
It's not really clear. And that's one of the challenges with studying any of this sort of homogenization stuff. Like, I don't really know what is a good 5 gram histogram. What's that supposed to look like, right? So all you can make are really relative statements. You can say that this is bigger than that and whatever, but it's really hard to say things like, and this is above some threshold that I would sort of intuitively consider to be bad, because I don't really know. The place where you can start to do some useful work here is to say, okay, but here's a downstream application for which this matters, and I can look at how this impacts performance on that downstream application, even if I don't know what these raw numbers mean on their own. Here's a similar version of this. If you don't know, many computer science peer review, conference peer reviews are public, and you can just download them. And so if you do that and you look for the occurrence of a choice set of words in those peer reviews, you will find huge spikes around 2024. And this, according to the authors, and this, again, not the only plot they have in their paper, they have a lot more robust analyses, but I think this is a demonstrative application of this, where they basically say, language is super high dimensional. I don't really know how to tell you that it's gotten more similar, but I can pick out these 6 words that have jumped all at the same time and are all very sort of ChatGPT sounding words. And so that gives you some evidence that there was a lot of AI use in peer review right around this.
What does this say? They're all adjectives.
I don't know. I mean, in part, the nouns are sort of more specified by the paper that you're reviewing. Like there's sort of more factual stuff there. Whereas the adjectives, you can choose to describe anything as commendable, right? So you have more flexibility in how you use your adjectives, and therefore perhaps.
So I guess what I was asking is, the LLMs use more adjectives.
I don't know actually. And so, but that's exactly the kind of thing that you do there. You could just classify all these words and then say, do I see it spiking point? Right. And in practice, like the pre-2022-ish to post-2024-ish difference is what people use for a lot of this, like, what is the impact of AI on X? Because that's, that people weren't using large language models in 2020, and many people were using them in 2024, 2025. Let's look at the difference between those.
I think maybe non-academic writing is more technical.
Well, I guess the question is like, it could be that the humans are using meaner adjectives.
It could be.
Or it could be that they just use less adjectives.
Yeah,
And GPT is just adding in some nice things before it gives the why I'm rejecting.
I suspect, I should go back to this paper. I suspect that they actually have some answers to your question. Okay, and then the other version of this is to create geometric structure, basically. So our way of saying condition A is more correlated than condition B is to basically say like the average cosine similarity between embedding vectors of things produced under A is closer than it is under B. There's a typo on this slide. One of these should be in next slide. Okay, so that's sort of the other version of this where you say, I don't want to specify 6 adjectives and I don't want to look at n-grams in particular. I'm just going to say like embedding vectors sort of capture a bunch of different things about text or images or whatever. They capture style, they can capture substance, so on. And I'm just going to ask, do those look more similar with AI than they do without? That's kind of the version of this question that people tend to ask.
Can I ask a very ignorant technical question that's been bothering me since we're on cosine similarity? How did they decide the origin? Because like if you put the origin at a different spot in the vector space, you get a different cosine. And this has bothered me for a long time.
Good. Okay, so the origin is determined by like regularity and normalization constraints that try to keep these things all sort of far apart from each other, but centered around a particular spot. And so there's sort of implicitly an origin when the embedding model was trained, and you cannot change that between when you train the embedding model and then when you actually use the embedding.
So in the context of like words, like these vectors and words or phrases, probably is the right term. The origin is like the average phrase. I'm just having trouble.
No, because in general, you don't want these, like most embeddings don't really go into negative cosine distances. So they all kind of stay in positive orphans somewhere. Really what a lot.
It's your modeling like co-occurrence probabilities based on the inner product, like what the vectors is on, right?
So it's going to depend a lot on how you trained your embedding model. The big ones that people use today are typically they actually just take some large language model and they like snip off the top of it and then take the sort of last layer output as their embedding. Right, so it's not trained according. Sometimes they'll like do additional fine tuning on top of that, but like the way that the base model is constructed is you just train some autocomplete engine. You just chop off the thing that translates from like the last layer of the neural network into what is the next token, and you just call that your embedding vector. Right? Why does that work? I don't know. It happens to work pretty well in practice, in part because like I don't know. The sort of last layer is supposed to capture all of the information in the sentence so far, and so. You know, that might make for a good, useful embedding. But again, why it works is like a little bit of.
But still, like the transformer is using that functional form essentially, right? So that's what gives meaning to the functional form.
It's just hard to know exactly what's going into them because it is just some black box that somebody else trained and you're using as a consumer. Many of them are fully open source, so you actually know what the training process was, and then some of them are open weights, so you just can inspect the weights yourself if that does you any good. But this makes it hard to do theory on these things. It makes it hard to really know what you're getting when you're saying high similarity, because like it could be picking up on style features, it could be picking up on substance, it could be failing to recognize that these two things are actually similar because it just like doesn't know for some reason. And so all of these are just heuristics that you're applying. Okay, so an example of this, this sort of RCT, half the people get AI, half the people don't. There've been a bunch on AI in creative ideation. So you run these RCTs that say, you know, this group of participants doesn't get AI, this group does. Come up with creative ideas for some particular task, right? So business ideas or short story ideas, that kind of thing. And you get some very consistent results across these RCTs that basically say, in the absence of AI, people are individually less productive, like they have fewer ideas, less detailed ideas, and so on. When you give them AI, they become more individually productive, so they have more detailed ideas, more ideas, but those end up being more similar to each other. And actually the collective produces less, because in my stylized diagram here, you went from having 2 ideas before to 3 ideas with AI, but those are the same 3 ideas as everyone else. So collectively, you haven't actually learned very much, right? And that forms some of the basis for these worries about like what is AI going to do to scientific ideation if all of us are just using our AI models to as like a thought partner to brainstorm research ideas with? Like, are we all just going to come up with the same research ideas or execute them in the same way?
Clarifying question again, going back to your so or to this section, are they all using the same AI or different types of AI?
Great. In both of these studies, actually, they're using the same model, right? But importantly, they could be using it in different ways, right? They're not typing in exactly the same prompts. They can be doing all sorts of different things with it. But they are getting more similar ideas as a result, right? And they're doing the same task, right? So that is the force that seems to be pushing them in the same direction. I'll talk more about experiments that look like this tomorrow as well. Okay, and so the way that you measure this convergence is you basically look at the embeddings of all of the ideas that get produced. Here they had, this was one of the studies where they actually did not give people AI directly. They gave them access to ideas that were produced by generative AI, I believe. And you find that the sort of similarity distributions look more and more similar the more AI generated ideas they are given, right? So humans on their own have like a similarity density that looks like this black line over here, and it starts to shift out towards the right. So you get more and more similarity, both to each other and to sort of AI ideas when you give them more access to AI. Okay, so this is sort of the result that you should expect from a study like this, and you might actually take this as evidence that like embeddings are capturing the thing that intuitively you think similarity should mean here. I'll give you one more example for this. So you asked, can you use this to detect AI? So we have a paper that have not yet put on the internet, but we will soon, on using AI trying to do AI writing detection. So one thing that you find is actually, as it currently stands, AI writing is very, very detectable. Just anything that you get out of a model off the shelf is going to be very, very instantly recognizable as AI. There's a bunch of services that do this. So they claim things like 99% accuracy on whatever inputs they're getting. The current approaches to doing this type of AI detection are basically built on supervised machine learning that says we have some text that we know to be human written. A lot of that is text that was written pre-2022, so we know it to be human written. And then we can generate as much text as we want that we know is AI generated. This gives us a labeled data set. We train a classifier. We can now label things in the data set. If you look at this plot, this is a sort of a PCA kind of thing. On this blue blob of text is human written, and then the colored blob of the other colors are generated by different large language models. And you notice that they aren't all coming from the same distribution, but they all are pretty separable from the human distribution, right? It's pretty clear what is written by humans and what is not here. I believe the length of each piece of text here is like a sentence. Okay, so this is even at that level, they're very, very distinct. Okay. And despite this, there's reasons to believe that you shouldn't just be relying on simple supervised machine learning here. One reason that it's bad is that this is actually, in a lot of cases, a more adversarial setting where, like, let's say you're a student, you're trying to submit some AI-generated writing for your homework. How do you get around the fact that your teacher is going to be running it through Pangram, which is one of these services that does AI detection? Well, there's people building services on the other end called humanizers, which basically says you put in some text, it'll rewrite that text to make it not sound AI generated, right? And they have access to Pangram as well. They can just ping that classifier and try to jump on the other side of the decision boundary effectively, right?
And it's literally how earlier generation of generative AI was working with.
Yeah.
To adversarial.
Yeah. So this sort of humanizing rewriting stuff is actually quite common. There's like Google Drive plugins that you can now use that'll just like automatically do it in one click for you. And so, yeah, go ahead.
Is the accuracy claim actually true at sentence level? They have 99% accuracy.
So they have the Pangram API actually requires you to give them more than a sentence before they're willing to issue a prediction. In our more limited setting, the thing that we're doing here is archive abstracts taken from the 2010 to 2020 era, and then you can just like rewrite those abstracts using AI. At that level, it is really easy to separate them. Now, they're solving a slightly harder problem in practice. They have a broader distribution of text that they're dealing with. And so they have that level of accuracy, or they claim that level of accuracy on like a couple hundred words, I think, or maybe 100 word minimum. whereas in our more limited set, you can do it with way fewer words. But in general, you shouldn't expect supervised machine learning to work particularly well in these adversarial cases. There's also worries about what happens when distributions shift over time. For example, GPT 5.5, I think, came out while we were writing this paper, so we actually just immediately ran it through its outputs through Pangram, which is this 99% accuracy claim, and it had way lower accuracy on this new model. We ran it again right before I made this plot, and it's actually much higher now. Okay, so in that time since they released the new model and now they've actually adapted to this new thing. The thing that I think is really interesting here is you can actually leverage the fact that not only is AI generated text different from human written text, it's also more self-similar. And you can actually use that to build classifiers that don't rely on this purely supervised methodology. In particular, you could do what's called semi-supervised learning or positive unlabeled learning that basically says, I have some text that I know is human written, and I have a bunch of text I don't know whether it's human written or not. Find me a good classifier in this space. And what it'll do is basically find a classifier that keeps all of the human written text classified as human and try to classify everything else as not. And that ends up working pretty well in this setting. Because now I don't need to worry about this sort of adversarial humanizer stuff. I don't need to worry about distribution shift. As long as I think that human writing, I have a pretty good sense of what that looks like, I can detect things that are not that. So it's sort of related to outlier detection type of methods, but it's a blend between that and supervised learning. Okay, the technical details I'd say not super important here. The thing that is interesting is you can use this sort of homogenization of AI writing as a feature. So for example, if everyone is running their text through the same humanizer, that actually starts to develop a recognizable signal, and I can figure out what that humanizer written text looks like, even if I didn't have a bunch of samples of it from before.
It's interesting, of course, is that the humans also seem to have their own monoculture, right?
Yeah, and this is like not lab participants that we took, right? These are just people writing archive abstracts on the internet. This is just like what science looks like.
Yeah. So, but it's not obvious like which one's more heterogeneous in some sense.
Absolutely not, no. But what is sort of clear, at least from what we can do, is you say like, all of this has to be human, all of this can be whatever it wants. Find me a classifier and it'll pick a decision boundary somewhere there, basically. Okay, I'm going to wrap up by talking about, to Max's point, some of these more normative questions that I think are, in my mind, open questions. So one of them is around the systemic exclusion point. The worry here is that you don't want to be the candidate who gets rejected by all firms or the applicant who gets rejected by all banks. And it was useful previously to have a market where I can, go to a bunch of different independent people and hope that I get a good outcome. I think I'm not super convinced by this objection. I think there's some merit to it, and I think there's some settings where it has to be made particularly precise. Some of it matters in like, what kind of market are you working in? Are there externalities and so on? So for example, a hiring market is very different from, like if you think of, I don't know, there's a bunch of film award ceremonies. You wouldn't want them to all have a monoculture over who they're giving those awards to. Like there's some of the point of having those different award ceremonies or different awards is that they actually make different choices, right? There's no point in having the same awards given to the same movies every single time, right? So exclusion on that front might actually be a bad thing. That is a setting where the externalities are quite different though, because one movie can actually accept multiple awards in a way that one job seeker is probably only going to have one job, right? So the type of market and the externalities matter there. Okay, so.
But there you sort of don't care again as much about the inequality between movies, and it's more again your information story.
Yeah, so maybe it's the information story, but maybe it's actually like, I think it is beneficial for indie filmmakers to have a place where they have opportunity, or I don't know, different directors to feel good. So I don't really know why we have award ceremonies, to be honest. That's maybe a separate question. But there are questions that are around like, is randomization desirable? Do you want some kind of uncertainty or inherent uncertainty that comes from flipping coins somewhere? Is that incentive compatible in some way? Even if you think it's socially good to randomize, it's probably not individually good to randomize. So how do you reconcile those? So there's some sort of interesting economic and normative questions there. The place where I feel the most confused is around this question of agency.
But like the randomization in a way is like reducing the individual level randomness, right? But you have like one common randomness as opposed to many independent ones, and it averages out like how much.
Yeah, so the proposal, so Katie's proposal here is everyone should have independent randomness. So when you are, let's say, doing college admissions or hiring or something like that, you should be flipping coins. Every college should be flipping coins independently somewhere. And that's going to
But then the
be.
intuition is more like a law of large numbers or whatever reduces the variance at the individual level.
So at the individual level, maybe it'll increase your variance. Like, let's say world number one, we all apply an SAT score cutoff. World number two, we flip some coins around that SAT score cutoff. At the individual level, like every applicant's outcomes are going to be higher variance there. Maybe collectively, there's more sort of, or less congestion on the applicants. Sorry, what was the?
Sure, but like we can talk about that.
Yeah, sure. So that's part of her argument is that we should do some amount of randomization because that'll lead to less individual level inequality because like you'll get lucky over there, I'll get lucky over there, and on average it all washes out.
College thing seems like a game of musical chairs. Like if there's a fixed ratio of applicants to spots, then in the end, every applicant is going to end up in a spot.
Yes, and so that is the objection to this type of proposal. Yeah, and so that's what Brian and I had written this paper, trying to make some version of this point, and then also think about like what are markets where that you don't have that musical chairs kind of out. The other thing we started thinking about in that paper is, which again I really don't know what to think about, is this question of agency. Is monoculture going to change the way that we specialize? Is it going to change how much effort we put in? Is it better to put in more effort or actually less effort if you know that everybody's evaluating you on the same criteria? I think there's an interesting formal modeling opportunity here. I have some thoughts and not enough time. So talk to me if this is interesting to you. And then I'll try to close just by asking, what is this going to look like going forward? So is this a persistent phenomenon that we're going to see, or is this all going to disappear in 5 years? There's a few responses to this that I think are worth going through. One is that from a practical perspective, consistency is actually desirable in a lot of applications. You don't want your model to tell you something different every single time you interact with it. You don't want it to behave differently every time. And so there is a growing body of literature actually on trying to get more consistency out of these models that says, like, if you have instances where 5 different questions or 5 reformulations of the same question give you 5 different answers, we should actually train models not to do that. So there's a literature that tries to do this. It's also become kind of apparent that generating high quality random variation is hard. So even if you wanted to build in some source of more heterogeneity or randomness into a model, it's not trivial to do this. And a lot of efforts to do this basically are making some trade-off between like the quality of what you're getting and how much heterogeneity across the distribution you're getting. There's some intersections with personalization, which I think are interesting. So one way to get models to behave differently is to get personalized to each individual that's using them. In general, this faces a little bit of a communication bottleneck where somehow I have to convey everything about me to this model in order for it to be personalized to me. Maybe it's going to learn from our interactions. Maybe we're just going to, I don't know, give me some sliders that I can adjust. I'm not really sure what the right way of doing this is. There's some.
This also, I guess, gets it like how we have almost the opposite normative theory around a lot of like social media, right? Like all the echo chamber, polarization stuff, which is exactly the opposite of the monoculture.
Exactly. And so that's the question, like, is consistency a good thing? Is it a bad thing? Do we want your model to like reinforce your beliefs all the time? Or do you want it to just like tell you things that are true? I think that's an open question. So better personalization may mitigate this monoculture, but maybe to Max's point, at what cost? There's also somewhat related to the literature on steering models. So how easy is it to sort of steer them in the direction that you want to? This actually want to send those papers, so maybe he'll chat about this a little bit tomorrow. And the last thing I'll say, I know putting math on the last slide is not the right move, but the last thing I'll say is like there's good technical reasons why we actually don't see a lot of variation across models. So to your point, is it because of the training data is all kind of the same? In some sense, yes, but there are good technical reasons why our post-training methods lead to mode collapse, where you sort of converge on a very spiky distribution. The technical explanation for this is the way that the dominant ways of training these models through reinforcement learning are actually miscalibrated in the sense that the correct distribution is not loss minimizing. It's instead what you get when you train these models is you're optimizing some combination of give me the right answer, but don't deviate too much from the base pre-trained model. And you do this via some regularization term. It turns out that the thing that minimizes or maximizes that regularization term is not a proper scoring rule. And so what you get is you get mass concentration on the high likelihood outputs, and you sort of evacuate mass from the low density outputs, right? In this, so
Is this just a statement that they're doing regularization wrong, or is this?
not necessarily wrong, because if you throw away the regularization, you get garbage. So you need some amounts of
But
regularization.
like, is there like a different way of doing the regularization that would be a proper score?
The proper score can't be biased, so
Right.
I would say no. It's inherent in the notional regularization.
So, I mean, you can, like, what you end up getting is a distribution that sort of satisfies this property, right? Where it's proportional to like the output to some exponential. That beta over here is a coefficient, sorry, this is the wrong. Yeah, this beta over here is a coefficient on your regularization term. In practice, if you set it to be 1, you would get in principle a proper scoring rule, I think. But in practice, this number gets set to like 0.1 or 0.01 because if you have too strong regularization, post-training does nothing. So the one way to make this a proper scoring rule is to change the objective effectively such that the model doesn't change. And if the model doesn't change, sure, it's a proper scoring rule, but like you haven't learned anything. So somehow interpolating between these two objectives of changing the way that the model behaves, but also not changing it too much, seems to be leading to some form of mode collapse. Now, in this paper, this is from a bunch of colleagues at MIT. In this paper, they propose some alternatives that are like heuristics that seem to do a little bit better, but it's not a solved problem. And there's a like very large body of literature now on it's called distributional alignment or pluralistic alignment, where they basically say, look, we have these models. They should be giving us things that look like samples from a human distribution. Instead, they're just giving us one answer. Let's say I wanted to train a model that would answer like survey questions proportional to the way that humans would answer survey questions. How would I do that? That's the distributional alignment problem, and it's very much an unsolved problem. Okay, so I will wrap up here. Sorry it took so long. I think of this question of monoculture as just a useful analytic lens that draws from a bunch of different fields and can be applied in a bunch of different fields. So you see some applications in computer science, economics, law, psychology. And it has this very basic structure of shared information leading to shared behavior. Some questions that I found generative. Where are we implicitly relying on independence? What is the interaction with market forces? So are they encouraging divergence in some ways? And what is the interaction between quality and or efficiency and sort of correlation or shared information? So thanks again for organizing. Looking forward to the discussion.
Yep.